Good afternoon, everybody. My name is Mark Apel. I'm the Environmental Projects Coordinator for Cochise County Engineering and Natural Resources. And over the last year, I've had the privilege of working as one of Cochise County's representatives on the Cochise Conservation and Recharge Network. And today with my colleague, Holly Richter from the Nature Conservancy, we will both be presenting our slides and how this network works over here in the San Pedro Valley. And with that, I'd like to introduce Holly. So take it away, Holly.
Thanks, Mark. And thanks so much for inviting us to share our story about our work on the San Pedro River. It's been really interesting work, and it's involved many people over many years, and hopefully some of the lessons that we've learned in this area can be helpful for other areas, although I guess I'll also mention that, of course, every watershed and every valley has different challenges. So it'll be interesting today to compare our challenges and our lessons learned with you folks. And again, I apologize if I can't hear anything that you're saying, and I'm depending on Mark to be my translator. But I've worked for the Nature Conservancy for, 5 years now. I serve as their Arizona Water Projects Director. I live in Palominas on the San Pedro, and I've really had the privilege of working on the science and research and the studies here related to groundwater and how we can best manage it collaboratively. So today, the Conservation and Recharge Network. I thought maybe I would just kind of dive in at first.
Excuse me, Holly. You're fading a little bit in and out, so if you could just keep the microphone or the telephone close to you. I'm also hearing some other noise. I'm not sure if anybody else is tuned into the seminar, but if they could please mute their phone or their computer. That would be their microphone on their computer. That would be great. Thanks. Sorry, Holly. Go ahead.
Yeah, no, I'm talking as close as I can to the mic now, so hopefully that's better.
Okay.
Okay. Let's move to the first slide, if you would, Mark.
All right.
Groundwater is really a kind of a mysterious phenomenon of nature because we can't see it. We know it's under our feet. We know it supplies the water to our wells. But frankly, it moves in mysterious ways because as it moves underground, the ground surface, of course, there's different areas that
Holly, I'm sorry, you're fading in and out again. I'm not sure if you're moving your telephone around or not.
I'm like 1 inch from the phone talking. Oh no. Be better at this point. So Mark, I can just continue until it's your turn, and then switch phones, or I can switch phones right now, depending on what you think is better.
I'm getting a message here. It says bad network quality. Your network is causing poor call quality. Try switching to a different network. I think let's just keep going. I think it'll work itself out.
Okay, great.
That sounds good now.
Okay, I'll try to talk really loud. But groundwater does move underground. Most in our areas, both in the San Pedro Valley and over where you guys are today, most of our rain falls on the higher elevation mountain ranges, as I'm sure you're aware, and then sinks into the valley floor and moves to the lowest point of the valley over time, very slowly underground. And so, as this illustration shows, that lowest point in the valley many times is a flowing stream or river, but not necessarily in all watersheds. And so, the one thing that is certain is that groundwater does move to the lowest part of the valley over time, and sometimes it's obstructed by rocks or impermeable layers, but that it is moving, and it's very complex because we can't see it. So, when we pump water, it's very hard to understand exactly what implications that might have, not only to our own wells or other people's wells or to rivers, because it's hard to know exactly how the water's moving. But this is one of the things that I think a groundwater model can really help us with, because it simulates, it's a three-dimensional kind of a prediction of how water moves underground based on the things that we do know. So this is in a natural system. This is how water flows. And Mark, you want to move to the next slide? When we pump water, we intercept its flow underground, and depending on dropped right near the well, and you might have heard that term called cone of depression. But that's what this is what it references, is that drop of the water table right at the point of the well where it's taking water out of the underground aquifer. So this is sometimes what we worry about, is if the groundwater sinks too low from pumping, obviously that not only affects our own well, but other people's wells, and it can also reverse the flow of water away from rivers or other points where the water was moving originally. So we want to maintain a groundwater level that is not too deep, and this is the challenge to groundwater management everywhere. And the thing that we're trying to do over in the San Pedro is the reverse of what a well does to the water table. We actually, instead of taking water out of a well, we want to make sure that we also put water back in certain points to compensate for the water that we need to take out. And that's called recharge. Some people call it groundwater replenishment. But we're going to talk today about how not only can we make sure that we sustain the water for our own use, but how we can sustain groundwater levels for rivers as well. And so that's just kind of in a nutshell, kind of the purpose of today's talk. And I hope folks have questions. I would ask, given our technology challenges today, that if we could hold those questions to the end, it would really be appreciated, just because, for one thing, I can't hear you. So, okay, next slide, Mark. Thanks.
Mm-hmm. Oh, just a second. Trying to get over there. There we go.
All right. This is just a map of the watershed along the San Pedro, and I'm sure many of you are very familiar. We're right over the hill from where you are today. San Pedro flows out of Mexico, and it flows past Hereford and Palominas, and Sierra Vista downstream, past St. David to the lower San Pedro. The area that we're going to talk about today, and the projects that hopefully will be informative for you guys to consider, are in that shaded area in the middle that's a little bit darker, and we call that the Sierra Vista subwatershed. And so that's the area that includes Fort Huachuca, Sierra Vista, Palominas, Bisbee, and Tombstone. And that's the area where we've really focused a lot of these groundwater replenishment or recharge projects over time. I guess I just want to back up about 20 years before I say anything else and say, because groundwater is so complicated and and invisible, frankly, we needed to develop the science that could predict how much water we had where, and what were the best decisions that we could make about increasing water supplies and using the ones that we have wisely. And so we actually started collaborative science here back in 1998 with the formation of the Upper San Pedro Partnership. And you guys might have heard about that group over time. It actually originated, it was part of an ADWR Rural Watershed Initiative group, but the bottom line is that it started with a purpose of creating this tool to predict groundwater and its movement and how we could best manage it. And we spent several years creating this predictive groundwater model, which really did inform a lot about what we could do that was positive and helpful in the area. And we developed it with the U.S. Geological Survey, many scientists, but also a lot of citizens and concerned folks that came together to really build this thing together and to understand the challenges and to come up with different alternatives and to kind of test them out with these different predictions. So the thing that I found really exciting as a scientist was not only that it was great science, but that it was collaborative science developed together to answer the questions that everyone thought were as important. So that's just a nutshell about the Upper San Pedro Partnership. And I just wanted to give you some examples of what the science, how those tools were used over the years that we worked together. Next slide, there we go. So this is the output of one of these, of the groundwater predictive model, and it actually shows the San Pedro Basin in the U.S. and Mexico. And it gives a forecast all the way to 2100 about how groundwater depths would change over time if we didn't do anything else than what, the kind of the status quo. And you'll see that those red areas actually grow over time, and those red areas are the places where groundwater is deepening over time, or that's where we're seeing significant drawdown. And so there's actually, if you look in the year 2000, it showed that there were kind of three separate areas that had those warmer colors. Around Sierra Vista was a kind of a municipal pumping center where groundwater depths were lower than the surrounding area. There was another one around Palominas that was some water that had been pumped for irrigation in that area. And then down by Cananea for industrial uses with the mines. And over time, these different pumping centers changed, or at least the model predicted that they would change, with continued pumping and removal of water from underground. And if we did nothing, this is what it would look like. And so this was kind of this was our challenge. This is what we wanted to influence and to change, and to see if we could keep the groundwater from not becoming so deep in such a widespread area in the future. Next slide, Mark. So once we kind of had an idea of what that challenge was, if we didn't add any projects or do any additional measures, then we started saying, well, what if we improved groundwater conditions in a couple of key areas? How would we do that? And we started asking questions about that. And this was, the groundwater model has a grid, and you can kind of see all these squares that are on this illustration. And really all I wanted to show you, without going into the complexities of computer modeling, is that you can ask a question of any square on the map. This actually shows us the Palominas area and what was called the Mansker Tract, which is now the Palominas Recharge Project, owned and managed by Cochise County. But we asked some questions of this groundwater tool, and we said, okay, well, if we turn this into a recharge site, number one, how much water would go into the ground if we could recharge it here? And then number two, how much benefit would we get by putting it in this particular location? And so the next slide kind of shows that. And kind of like a contour map, a topo map, this actually shows the formation of a groundwater mound underground. That's what those concentric circles show. And it shows how the water would actually mound up under the ground surface at that recharge location if we did recharge there. And it predicts how that would happen over time. It also predicts how much it would influence the stream flow in the San Pedro right next door over time. So this became a really useful tool for us, and one that I can't emphasize enough is that we could start to do what-if scenarios of what if we did recharge here, what if we did recharge there, how would that address the groundwater storage over time, and how many projects would we need to do, and what was the smartest location to do them if we really wanted to think about this at the watershed scale. And so we were lucky to have the science that could ask that question, and it pointed us in this direction of creating a network of projects that could collectively meet the environmental, social, and economic needs. And we came up with this proposal for 8 different projects along 25 miles of the river. And we realized that we needed to take a subgroup of that larger San Pedro partnership, which, by the way, had 21 different member agencies, state, local, federal, nonprofits, business interests. They helped us develop the scientific tools and kind of frame the challenge together. But then there was a smaller group of folks that actually are the folks that would implement this group of projects. And I'm going to let Mark talk about the existing projects that the Cochise Conservation Recharge Network now has on the ground. But it's 2 municipalities, it's Sierra Vista and Bisbee, with the county's help, the Hereford Natural Resource Conservation District, and the Nature Conservancy. And this is the network of projects that we've come up with based on all this science we've developed over 20 years. And here's the map. You can actually see Fort Huachuca is kind of a tan color. The blue is the BLM's National Riparian Conservation Area. You can see Highway 92 in Mexico. And then the names of the different projects that we've now established to help improve the groundwater supplies in the area. Some of these are existing projects and some are proposed. So first we're going to go through the existing projects. And Mark, this is where I'm going to turn it over to you.
You bet. Thanks, Holly. As Holly was just talking about how we've strategically aligned these projects to be as close to the San Pedro Riparian National Conservation Area as possible, where we could have the biggest bang for the buck. And so that's why they're placed where they are, as well as taking advantage of some of the opportunities that came up in a few years back to acquire the properties that would allow us to implement these projects. So moving on to the first project that's been on the ground for quite some time, the City of Sierra Vista's Environmental Operations Park has played an essential role as a proof of concept project. So it became operational back in 2002 and consists of lagoons, constructed wetlands, and lastly, rapid infiltration basins where treated effluent is allowed to infiltrate into the ground. So all of Sierra Vista's wastewater is processed here at this plant, but then it's now being used to create a similar water mound that was modeled by USGS and the studies that Holly referred to earlier. In the past 18 years, the underground storage of water from this project has created a huge groundwater mound of deeply saturated soils in the aquifer, and they extend for miles around in diameter. The amount of water stored from this facility, like others in the CCRN, is quantified by monitoring wells, and this information gets reported on an annual basis. So in this picture, the rapid infiltration basins in the upper right-hand corner had been recently constructed, and the old irrigation pivots that used to use the treated effluent to irrigate alfalfa fields are still evident, but they are now retired. The basins on the left side of the photo are treatment wetlands. That's another way of recharging, but also creating some natural habitat for the wildlife in the area. It has been in the past a popular bird watching area. One of the biggest challenges with building recharge projects is where to get source water from. So treated effluent is one of those source waters for this purpose, since it is a steady supply of water and usually increases in volume over time as the associated residential water use does, and commercial use. We can discuss why centralized treatment facilities like these can be more effective for storing groundwater than individual leach fields later, if people are interested in that. Another project that we have on the ground that has been constructed since 2014 is the Palominas Flood Control and Stormwater Recharge Project. This recharge project conveys and collects sheet flow from rain events. So sheet flow essentially occurs in areas with relatively impermeable clay-like soils on the surface where water cannot easily get into the ground. Sheet flow is generally not subject to surface water rights in Arizona before it enters a natural system channel, so it can be captured and used for recharge. So a 10-acre detention basin was built, which then feeds into a constructed channel. The channel includes 13 smaller sequential basins, each with various infiltration enhancements. And some of those infiltration enhancements are like an infiltration trench filled with cobbles and rocks, or dry wells where water just flows down into a dry hole that's connected to the aquifer. These small basins are being used to compare the relative costs and benefits between different infiltration methods. So infiltration trenches, single chamber dry wells, double chamber dry wells. They're also being compared to basins with no improvements at all, just to see how the water would naturally infiltrate through the existing soil there, the natural soil. So far, the dry wells have the greatest infiltration rates, while the infiltration trenches have the most ease in sediment removal and lower initial construction costs. So what's interesting about this project is that there had been a large flood issue in Palominas that was so bad that it was actually flooding the school. The county was able to acquire this property with the help of its partners like the Nature Conservancy and the Walton Foundation for the purposes of having a dual purpose. One, to help control floodwaters and redirect floodwaters that were really wreaking havoc on the community of Palominas and the school, redirecting those waters into basins that would then also recharge the regional aquifer, the local aquifer there, that then in turn will help sustain the flows in the San Pedro River. So this project is not directly connected to the river or the Sprinka, the Riparian National Conservation Area. However, any recharge that we see here actually is helping to sustain the aquifer underneath this area, that in turn feeds the flows in the river. So just the next project that I want to talk to you about a little bit is the Three Canyons Water Conservation Project. So just north of the Palominas Flood Control and Recharge Project lies 3/4 of a section of a previously irrigated agricultural field that was placed on the market for development for several years. This property is now held by the county, and large volume pumping, 2,600 acre feet a year, has been permanently retired by a conservation easement now held by the city of Sierra Vista. And only a maximum of 12 houses will ever be allowed on the property if that's what the county decides to do for using some of that property for that purpose. Active irrigation occurred here from 1996 to 2005 and had clear impacts to the flows in the river in the region. Today, there's a shift from pivot irrigation to dryland grazing, where Cochise County, as the owner of this property, is committed to experimenting with alternative intensive grazing management systems as a means to increase organic material on these ag lands, control sheet flooding, and enhance infiltration of stormwater. So we're multitasking by these areas that the county now owns. And the last existing project that I'd like to talk to you about today is the Horseshoe Draw Sediment Control and Stormwater Recharge Project. This project was constructed on the Ladd's family San Jose Ranch, just south of Hereford, in 2017, with the help from the Hereford NRCD and funding from ADEQ's Section 319 grant program and the Howard Buffett Foundation. The project was later transferred to Cochise County. Before the project was constructed, a large head cut had been steadily eroding Horseshoe Draw upstream of its confluence with the river, and the flooding and sedimentation had actually resulted in road closures downstream of the site on Paloma Trail, effectively blocking residents from even getting to their homes because of how deeply rutted it would get and washed out. Drone survey technology allows us to monitor how much sediment is captured in the basin over time and compare these changes in sedimentation before and after basin construction. The amount of recharge that occurs within the basin and downstream channel is a secondary benefit to this project that is also being monitored. So Holly's going to take back over and talk a little bit about some of our proposed recharge projects that we showed on that map earlier.
Mark?
Yes. Oh, we got a question, Holly. Just a second.
I have a question. So what are we seeing? We're testing recharge, but are we testing water quality with those, like especially those dry wells as they recharge into aquifer? How is that affecting water quality?
Is that Myra?
Yeah.
Hey, Myra.
Yeah.
And nice to see you. I thought I recognized you back there. The Horseshoe Draw, we don't have any water quality monitoring going on at the Palominas project, but ADEQ does have water quality monitoring devices to see if there are any reductions in E. coli or increases in E. coli that could possibly occur here with the retention or detention of stormwater like that. So that E. coli is one of the constituents that ADEQ has identified in several places throughout the Sierra Vista subwatershed. And we work with them to see if they can piggyback onto our projects. And in fact, we're looking at talking with them about piggybacking onto one of the next projects that's coming up here that Holly's going to talk about in Coyote Wash. But they are actively monitoring down at the Horseshoe Draw facility right now. Does that answer your question, Myra?
Yeah, kind of.
Okay. Holly, are you still on?
I am. I'm ready to go.
Okay. Coyote Wash is up.
Yeah, good. So as Mark just alluded to, I think that one of the really important aspects of these projects really helps in a lot of ways, including finding ways to pay for them in terms of their construction and maintenance, right? So this next one, Coyote Wash Urban Enhanced Recharge, the top picture shows downtown Sierra Vista, part of which is in this watershed of Coyote Wash. And Coyote Wash is the drainage that actually conveys the most stormwater from downtown Sierra Vista. And that's a lot of extra stormwater, because when you look at downtown and you see all these parking lots and rooftops and sidewalks and roadways, all of that are surfaces where water cannot soak in. And so what happens is we get huge amounts of runoff, and we call that urban enhanced runoff. And that it creates kind of extra water, which a lot of engineers have considered to be a problem over the years, because you have to build bigger culverts and you have to get it off the streets, and you don't want people flooding away. But it really solves the problem as well. If you kind of flip it on its head and you think about it, is if one of the problems with aquifer recharge is finding a source of water, well, here's a source of water. It's this extra water that is produced in downtown areas. And so if we can just convey it to a location where we can get it back into the ground, it becomes a real asset or benefit to the community. And that's exactly what we're doing with Coyote Wash. It actually, like I said, it conveys the most runoff of any tributary in the San Pedro, because it's downstream of the biggest city and hardscape, if you will, that we have. And so not only is it a great source of water, but when you put that runoff back in the ground instead of letting it just flow freely downstream to the river, it improves water quality. So that's a double benefit for a project like this. So in the case of Coyote Wash, there was an old abandoned gravel pit next to the channel itself that we're looking at here, and we're actually looking at converting that old gravel pit into a recharge facility that'll help get more of this back into the ground. So this is a proposed project. It's a great partnership with the Natural Resource Conservation Service, who's helping us engineer it and who has funded a lot of the design. So this is another example of a federal partner in this case that helped to fund the construction of the project. As Mark just mentioned, Horseshoe Draw was a state partner with the Arizona Department of Environmental Quality. So I think, again, in enlisting all of our partners from all levels of government and also the private sector is really important in getting these projects to happen. So this is one of our proposed projects, partially designed so far. And Mark, if you'll change the slide, we'll go to the next one.
Yep, the Bisbee Effluent Recharge. As we noted earlier, there are two major sources of water that we can use to recharge the aquifer. One is stormwater that we've been talking about the last few minutes, and the other is effluent. Just like the Sierra Vista Operations Park, we are working on a project where Bisbee can contribute to the recharge of the San Pedro and Valley aquifer. And so far, we have been able to negotiate an option agreement with the city of Sierra Vista to purchase a minimum of 200 acre-feet a year of treated effluent from the city of Bisbee and having it piped over to the river as close to the Mexican border as we can get it, because we are noticing that the reach of the river from the border up to Highway 92 in Palominas has been declining over the last years. And so we're seeing declining river flow, or surface water flows in the river there. And we're hoping that the Bisbee Effluent Project will help us actually restore some of those flows in the river through the aquifer and through aquifer recharge. So this agreement was signed back in 2019. And next.
Can I ask a question?
Is there a question?
I have a question.
Okay.
Can you hear me?
Yes. Is that Shar?
Okay. Well, Customs and Border Patrol is going to build the wall across the river. What is that going to do to these plans to try to get more water down there along the Mexican border?
Well, that's a really good question, Shar. It does complicate the situation quite a bit. The wall across the river shouldn't have any impact on the recharge plans in terms of where we would like to see the recharge happen. The recharge is going to likely happen just a little bit north and east of where the wall will cross the river. Our biggest challenge at this point is getting the pipeline from Bisbee over to this area, and that's something that we're looking into right now.
Gotcha. Thank you.
Holly, were you able to hear that question? Because I unplugged my headphones to see if and there's no echo, and I was wondering if you could hear that coming from that question from Shar.
I could hear Shar.
Okay, good. All right, I've been using a headphone because I thought there might be an echo, but there doesn't seem to be. So you're able to hear what people in Sunsites are thinking right now, but they're not saying much. They're not saying much at the moment.
Not sure about the back row, but yeah, okay. So there's a third project that's proposed, and we can talk about that one next. This is, again, the map. Those green areas are the different projects in this network of recharge projects, and it shows you where the Sierra Vista Environmental Operations Park, the EOP, is. Right next to what's called Bella Vista, but that's actually the Coyote Wash project we just talked about. And one of the things that we realized is that, again, thinking about what's the source of water for recharge, it'd be really nice to be able to recharge down at that Riverstone tract, which is actually upstream of the Environmental Operations Park. But we didn't have source water there that was available. And so right now we're in conversations with the city of Sierra Vista to actually take some of the water from the Environmental Operations Park that's been treated effluent and move it up to Riverstone so that we can get more benefits in that part of the aquifer. What it will enable is a wider distribution of that precious effluent that's generated by the city that can benefit both the groundwater and the river. And this is, again, how our computer modeling and predictive forecasting can tell us how to be most efficient with the water that we do have, where to put it, and how much. And without that science, we wouldn't know how important it is to move it to this other location. And so this is going to be an emerging project over the next several years as well. And that's the last of our new projects. And I guess the important part here is that you really can't think about one project alone as solving kind of a regional groundwater challenge. You have to think at the regional scale, and it'll likely take many things together. And so what we've come up with is these several projects, some of which are built, some of which are under design, which collectively could sustain the river, and the computer models tell us at or above the levels that the river flowed in 2003 can sustain that much water through 2075. And this is a heck of a good start. Particularly, under extended drought, this would be a real accomplishment if we could complete this network. And so we don't have all the funds required to build these projects yet. I will say that it's easier to secure the funding that's needed for these infrastructure projects when you ask for that funding with a really diverse consortium of people who all believe that it's the right thing to do. And that's another benefit of working collaboratively, I believe. You'll also notice that we are looking at the Babakamari River. We also have a recharge location there that we may be working on in the future as well. That's a really important tributary to the San Pedro. But in closing, I guess I would just say that, all of these decisions and investments are based on the very best technical tools and science that we could develop. And it took us a long time to do that. But I think in the end, it is really helping us make these tough decisions, not only for the river and nature, but for our local communities and all of us who have depend on groundwater and our wells. So